All right, welcome to tonight's video, the second part of part one. All right, so last time we talked about how to find the limits of the value of a function at a certain number. And so we're going to continue that with some more examples of piecewise functions. This first one is a step function. And we have to define this step function as a piecewise. So it's going to be x times. Now the step function, remember, is where it's the greatest integer less than or equal to that number. So the number here, it'll be 2 if x minus 2 is between 2 and 3. It'll be 1 if x minus 2 is between 1 and 2. 0 if x minus 2 is between 0 and 1. It'll be negative 1 if x minus 2 is between negative 1 and 0. It'll be negative 2 if x minus 2 is between negative 2 and 3. Or sorry, negative 1. Sorry. Negative 3 if x minus 2 is between negative 3 and negative 2. Negative 4 if x minus 2 is between negative 4 and negative 3. Negative 5 if x minus 2 is between negative 5 and negative 4. And last but not least, negative 6 if x minus 2 is between negative 6 and negative 5. And remember, at the top and the bottom, you need the two dots to continue that this would go on forever and ever. Now, the reason I started with 2 and ended with negative 6 has to do with the values it's asking me. Because if I solve this and I add 2, that gives me 4 to 5. So that covers f of 4. Because if I'm finding 4, the limit as x approaches 4, I need to go from the left and right. So I need to go at 4 and then less than 4. And then the same thing at the bottom, it's negative 3. So if I add 2 here, I get from negative 4 to negative 3. So that'll cover the left and right as well. So that's why I chose those. So now to get the whole function, because I have to multiply by x, and I have to apply the add 2 to both sides of the inequality. So multiply, so it's 2x. All right, so applying the multiplying and then adding, this is what you come up with for the function, for the piecewise definition. So now, finding the limits, the first limit it wants you to find, sorry, I just got to scroll around here, is x approaches negative 3. So the limit as x approaches negative 3. And since negative 3 has different rules from the left and right, you got to do left and right. And then that'll give you the limit as x approaches negative 3. And then it also wants you to find f of negative 3. So if we go over here from the left of negative 3, left of negative 3 is less than negative 3, so it's negative 6 times negative 3, which is 18. But the right, so that's between negative 3 and negative 2, is negative 5 times negative 3, which is 15. So from the left, it's 18, but from the right, it's 15. So therefore, it does not exist, since the limit from the left does not equal the limit from the right. If you found f of negative 3, it would be 15. So now you have to do the same thing for 0. So I just wrote those out. So now looking at 0, to the left of 0 is negative 3 times 0, which is 0. To the right, between 0 and 1, is still 0. So therefore, the limit as x approaches 0 is 0, and f of 0 is 0. So now, last but not least, we have to do this for 4. I'll come over here and do that. So with 4 from the left, so 4 from the left is here, is x, so it's 4. From the right, between 4 and 5, it's 2x, so it's 8. So the limit as x approaches 4 does not exist because the limit from the left does not equal the limit from the right. And f of 4 would be 8. All right, so the next one, notice if we substitute 2 directly in to the function, we get 2 minus 2 over, now if you put 2 in there for everything, you get 0. So 0 over 0 is indeterminate, which means we have to simplify k of x. And we want to factor this. Now, there's 5 terms and it's a 4th degree, so it's pretty hard to factor. However, we want one of the factors to be x minus 2, so we can cancel. So, in order to figure that out, you can divide. You can either do polynomial long division or you can do synthetic division. Bring down the 2, multiply, bring down the 2, add. Multiply, add, multiply, add, multiply, add. So notice the remainder is 0. That's what we want. So that means the remaining factor is 2x to the third plus 3x plus 1. So I don't know if you caught that, but when we simplify by factoring, we then substitute in the 2 in, and then we get 1 over 23. Now k of 2 is undefined because x cannot equal 2. So for the next one, this is a piecewise function. Remember the signum function. It's 1 if x is positive. It would be 0 if x is 0, but we can't have 0. So then it's going to be negative 1 if x is negative, which then means if we simplify that and divide, we have x if x is positive. We have negative x if x is negative. So that's our piecewise definition. So the limit as x approaches 0 from the left of g of x, when it's 0, is 0. From the right of g of x, it's also 0. And so the limit as x approaches 0 of the function is 0. G of 0, however, is not defined by the function. The next one is another piecewise function. So it's x times x if, if x is greater than or equal to 0. Some of you might define 0 separately. I'm not. And it's negative x if x is less than 0. So then you multiply, and you get x squared if x is greater than or equal to 0. Negative x squared if x is less than 0. So that means if you're finding the limit as x approaches 0, you do have to go from the left and the right. From the left, you put in 0, you still get 0. From the right, you put in 0, and you get 0, which means the limit as x approaches 0 of the function is 0. And then f of 0, however, now this is defined, so f of 0 is 0. Last but not least, we have another piecewise function. So if we're finding the limit as x approaches 2, well, notice 2 is the changing point. It has different rules. From the left, when we put it in the less than, 2 squared is 4 times negative 2 is negative 8 plus 11 is 3. The limit as x approaches 2 from the right, that's when it's greater than. So 4 times 3 is 12, minus 8 is 4. So that means the limit as x approaches 2 does not exist, because the limit from the left does not equal the limit from the right. F of 2 is undefined. Now we're doing the same thing for negative 1. Now negative 1 is not a changing point, so therefore we can just directly substitute into the top, because that's where it's less than. So negative 2 plus 11 is 9, and f of negative 1 is also 9. And then the same thing for 3. It's greater than 2, so 9 times 3 is 27, minus 8 is 19. So f of 3 is 19 as well. All right, that concludes our video for part 1. If you have any questions, please feel free to ask. Have a good evening.